So today we're looking at section F here, modeling using linear systems, and this is going to be split into two separate lessons here. But up until this point, we've been solving equations, solving systems of equations. We solved them by graphing, by substitution, and by elimination. But they've always given us the system of equations that we need to solve. So today we're going to start taking it one step further here, and we're going to look at situations where they just give us a description of that situation, and we have to come up with the equations that we're going to solve. So we want to be able to solve problems that can be modeled, that's coming up with the equations, and then solved, that's solving the equations, using these systems of linear equations. And we're going to divide this into two parts here. The first are going to be what I call mixing type problems, where we have sort of two things that have been combined together to give us, and they give us certain totals for those two things, and we have to separate out the number of those two things. And then in the next lesson, we'll look at problems involving distance, velocity, and time. All right, let's take a look at our first example here. So before we even start this example though, in questions of this type, there are two things that are mixed together and totals for these two things are given. Our task is to separate these two things that are mixed. So our first example, the Outdoors Club held a car wash to raise money. They washed cars for $5 each and vans for $7 each. They washed 45 vehicles and they earned $243. How many of each type of vehicle did they wash? So first off, let's identify what they're actually asking us here. How many of each type of vehicle did they wash? So this gives us a clue as to what our variables are going to be, because usually we pick our variables to be the answer to the question that has been asked here. So when they talk about two types of vehicles, what are the two types of vehicles in this question? Well, there are cars and there are vans. So these are our two types of vehicles that have been mixed together, cars and vans. So when we decide what our variables are going to be, we're going to say something like, let C be the number of cars, and let V be the number of vans. Okay? So we want to take out, we want to separate out what are the contributions of cars to our totals and what is the contribution of vans to our totals. Now, what are the two totals that I'm talking about here? Well, they tell us that they washed 45 vehicles. This is the total number of vehicles. Okay? And they earned $243. This is the total amount of money. All right. So part of that total vehicles is made up of cars. Part of it is made up of vans. Part of that total money comes from washing cars and washing vans. Right? So we're going to set up equations for those two totals that we have here. So we're going to have an equation for vehicles. And we're going to have another equation for, let's say, amount of money raised. So what do we know about vehicles? Well, we know that there's a total of 45 vehicles. How many of those are cars and how many of those are vans? Well, that's what our variables represent here. C is the number of cars, V is the number of vans. So the total number of vehicles is the number of cars, C, plus the number of vans, V. What about our money raised? Well, we raised a total of $243. Okay. How much of that came from cars? Well, we don't know, but we know that cars were washed for $5 each. So the amount that came from cars is $5 times the number of cars. Number of cars is represented by C. The other part of that 243 came from washing vans. We washed vans for $7 each, and we washed V vans. So if we add those two up, the amount from cars, the amount from vans, we get our total of $243. And this is our system of two equations that we want to solve. Now, how do we solve this? We can use substitution or elimination. I'm going to use elimination here. I'm going to take this top equation, okay, and I'm going to multiply it by 5, because if I do that, I will get the same coefficient on C in these two equations. So that first one will become 5C plus 5v equals 45 times 5, which that's the kind of thing that I have to put into my calculator here. So I'll do 45 times 5 to get 225. Now that I have those c coefficients matching up, I can just subtract these two equations. 5c minus 5c, those terms are going to cancel out, which was the whole point of the elimination. 7 minus 5 is 2v, and 243 minus 225 is going to give me 18. And from here, I can solve for v, dividing both sides by 2. V is going to be equal to 9. So that v represents the number of vans. Now we have to go back and figure out the number of cars. Easiest to do that using this equation right here. So I'm going to bring that down over here. I know that c plus v is equal to 45. If v is 9, I know that c has to be 45 minus 9. 45 minus 9 is 36. So there we go. I've got my value for c, and I got my value for v. Okay. And because this is a word problem, we want to end with a statement that says we know what c and v represent. So we can say, therefore, they washed 9 vans and 36 cars. So these are the steps that we want in every single one of our solutions here. We want to set up what our variables are, c and v. We want to set up equations using those variables that model our situation. We want to solve that set of equations and then to get our values of our two variables. And then we want a statement at the end that says we understand that we have answered the question. All right, let's take a look at our next example here. A weekend at a resort lodge costs $360 and includes 2 nights accommodation and 4 meals. A week costs $1,200 and includes 7 nights accommodation and 10 meals. Determine the cost of 1 night and 1 meal. Okay, what do they want us to find? Determine the cost of 1 night and 1 meal. So our variables are going to be, let n be the cost of 1 night, and let's let m be the cost of 1 meal. Because those are the two things that are mixed together in our totals here. 1 night and 1 meal. Okay. So what do they tell us? Well, they tell us a weekend at a resort costs $360. That's the total amount. Okay. And that includes 2 nights and 4 meals. Okay. They give us another total that is a total cost, $1,200, 7 nights, and 10 meals. So these are going to be our 2 equations. We are going to have the weekend, an equation for the weekend. And an equation for the week. Okay. For our weekend, the total was 360. Okay. And it was made up of a certain number of nights, 2 nights. Okay. And each night cost N dollars. We had 4 meals. Each meal cost M dollars. So 2N plus 4M gave us our total of 360. For our entire week, our total was $1,200, which that total cost was made up of 7 nights and 10 meals. And there's our 2 equations that we want to solve. So how are we going to solve this system? Well, this one, I think we should use elimination. In fact, I think we can only use elimination here. We've got to take both of these equations and multiply them by something to get them to match up. So this first one here, I'm going to multiply it by 7 in order to get 14 on the n here. And I've got to multiply this one by 2 to get 14 on here. So if I multiply the first one by 7, I'm going to get 14n plus 28m equals 360 times that 7 is going to be 2520. Okay. And then our second one, when we multiply by 2, 14n plus 20m is going to be 2400. So this one came down to here. This one came down to here. Okay. Now we can use elimination here. I'm going to subtract these two equations. Our n's cancel out. 14n's cancel out. 28 minus 20m is going to be 8m. 2520 minus 2400 is going to give me 120. And dividing both sides by 8 gives me that m is equal to 15. Okay. Then we'll go back to one of our original equations, this one right here. 2n times plus 4m is 360. So 2n plus 4, substitute the value for m in there, 15 equals 360. This lets us solve for n. 4 times 15 is going to be 60. Subtract 60 from both sides, 300. N is 150. Now, what do m and m represent here? Well, we can say therefore, one meal is $15, our value for m. One night costs $150. And make sure we put in the dollars in there. Okay? And that's going to be our conclusion. Okay. So our next one here also deals with money. All right. A lifeguard earns an hourly rate for 20 hours of work in a week. If she works overtime during that week, she's paid at a higher rate for the overtime hours. 1 week she works 24 hours and is paid $166.40. The next week she works 27.5 hours and is paid $200. Determine her regular and overtime rates of pay. All right, what are we looking to find? Her regular and overtime rates of pay. Okay, so those are the two things that are mixed together. So let's let them be our variable. Let R be her regular rate. All right, and that regular rate is for the first 20 hours. And rather than using O, because O looks a lot like a 0, we're going to use V, be the overtime rate. And that's for, after 20 hours. Okay, so what are we given our totals for? Let's see. One total that we have here is she earned $166.40 1 week when she worked 24 hours. The next week she worked 27.5 hours, but the total was $200. So we're going to need an equation for each of these 2 weeks. We'll say week 1 and we'll say week 2. Week 1, her total was $166.40. Now that was made up of working at the regular rate and working at the overtime rate. How many hours did she work at the regular rate? Well, she worked 24 hours altogether. 20 of those hours have to be at the regular rate because you have to work 20 hours at the regular rate before you even get overtime. Anything above the 20 hours has to be at the overtime rate. So 20 hours at the regular rate plus 4 hours at the overtime rate. What about the next week? She worked a total of 27.5 hours in the second week. Again, that's going to be 20 hours at the regular rate and this time 7.5 hours at the overtime rate. She earned a total of $200. So this is the system that we have to solve. Now this is beautifully set up to use elimination here. All we have to do is subtract these two equations because these two 20Rs are going to cancel out. If we do 4 minus 7.5V, we get negative 3.5V. 6640 minus 200 is going to give us negative 33.6. Divide both sides by negative 3.5 and we get 9.6. We need to still figure out our value for R. So 20R plus 4 times our value for V, 9.6, going back to one of my original equations, is 166.40. Let's do the multiplication first. 4 times 9.6 is going to give me 38.4. Subtract that 38.4 from both sides. 20R is going to be 128. And then dividing through by 20, R is going to be 6.4. So that gives us our two rates. So therefore, $6.40, our value for R, per hour, is the regular rate. And let's just say, what's it, 9.6? So $9.60 per hour for overtime. Because that's what they asked us to find, right? Determine her regular and overtime rates of pay. Okay, and those are the two rates. All right, our last question here is a little bit tricky. Let's take a look at it. One lawn fertilizer is 24% nitrogen and another is 21% nitrogen. How much of each fertilizer should be mixed to obtain 100 kilograms of fertilizer that is 23% nitrogen? Okay, so what are the things that are being mixed here? Well, first of all, what are they asking us? How much of each fertilizer? So our variables are going to be the amount of each type of fertilizer. So what are the two types of fertilizer that we have? We have one that is 24% nitrogen and one that is 21% nitrogen. Okay. So how much of each fertilizer? Let's say let F be the mass of 24% nitrogen, the 24% fertilizer. Okay, and then, I don't know, let's say W for 1. Let W be the mass of 21% fertilizer. Okay. Now, what totals do they give us? Well, they give us 100 kilograms here. That is our total mass. Okay. So we already have the individual masses. F and W is the mass of one, and W is the mass of the other. So we know that for our total mass, F plus W must add up to 100. What is the other total? Well, in this resulting mixture that is 100 kilograms, we know that it is 23% nitrogen. Okay, so how much nitrogen is that? Well, if it's 23%, whoops, 23%, right? So 0.23% times 100 is 23 kilograms. So 23 kilograms is the total mass of nitrogen, not the rest of the stuff in the fertilizer. So the total mass of nitrogen in the resulting mixture is 23 kilograms. Now, where does that 23 kilograms come from? Well, it comes from the nitrogen in our 24% fertilizer. The mass of that is F. How much of that is nitrogen? 0.24, 24%. And it comes from the nitrogen in the other fertilizer. The mass is W. How much of that is nitrogen? 21%, or 0.21. Okay? These are our two equations to solve here. Okay? So how would I solve this system here? I would get rid of the decimals by taking this equation here and multiplying it by 100. Okay? That's going to give me 24F plus 21W equals 2300, multiplying everything by 100. Okay? And then I'm going to take this first equation and I'm going to use elimination here. So I'm going to eliminate F by multiplying this equation by 24. So let's move this up a little bit here. Okay. If I'm multiplying that by 24, I get 24F plus 24W equals 2400. Now I can eliminate F by subtracting these two equations. 21 minus 24 is negative 3W, and 2300 minus 2400 is 100. So dividing both sides by, is negative 100. So dividing both sides by negative 3 gives me about 33.3 for W. F plus W equals 100. 33.3 in there for W. So F is going to be 100 minus 33.3, 67.7. There's my value for F and W. So sum it all up. We need 33.3. Let's see, what was the question again? How much of each fertilizer should be mixed? W is the mass of 21%, so 33.3 kilograms of 21%. And what's our value for F? 67.7 kilograms of the 24% nitrogen fertilizer.